Good morning, grade 5. How are you all? I hope you're staying at home and staying safe. So, we're going to continue with the unit 5, more about electricity. And the topic is what are electrical conductors and insulators? So, you would be doing in your pupils' book, page 98 and 99. And the homework for today is worksheet 6. So, your aim for today is that you're going to sort and identify materials into electrical conductors or insulators. And after the lesson, your success criteria is I can explain why some materials conduct electricity and why others don't. And I can test materials to check if they are conductors or insulators of electric current. Okay, now let's start. First view. Let's recall. An electrical current is a path along which current flows. You can see from the picture, current flows from the positive end of the battery to the bulb, from the bulb to the negative end. It's like a circuit. Okay, current can only flow when it's a closed circuit. What is a closed circuit? A closed circuit is that which does not have any gaps. Okay, it's all connected. The battery provides the energy in the closed circuit, and the current transports the energy from the battery to the bulb. As you can see in the picture, from the positive end of the battery you can see the arrows go to one side of the bulb, and from the other side of the bulb it comes to the negative end. So it's a complete circle. This is what an electric circuit works, how it functions. Let's do a small review quiz. Okay, let's see if you really remember what complete and incomplete circuits are, and do you think how circuits really work? So do you think the circuit will work? Look carefully. Yes or no? I'll give you a countdown. 5, 4, 3, 2, 1. No, it will not work because it's an incomplete circuit. Why? Because one end of the battery it's not connected to the circuit. It should be connected with the bulb. Now let's see the next one. Do you think this electric circuit will work? I know you remember this. There's an extra thing inside. There's a switch also. Do you think the switch is there to help the circuit? How? Think of your answer. I'm giving you a countdown again. 5, 4, 3, 2, 1. No, because the switch is turned off. This is the reason why it's not going to work. If the switch would be turned on, the circuit would be complete and all the current will be allowed to pass through it, and the bulb would light up. The last one. Now do you think this circuit will work? This electric circuit will work properly? Look carefully. Yes, it's going to work because it's a complete circuit and all the parts of all the components of the circuits are connected properly. So it's complete. So electricity is going to pass in this. It's a closed circuit. Now have you ever thought why some materials allow electricity to flow through them? And do you know what kind of materials allow electricity to flow through them? And this is what we are learning today. We are learning about electric conductors and electric insulators. So what is an electric conductor? And electrical conductors are materials that allow electric current to flow through them. That means if they are there in the circuit, electricity will pass. Those are called as electric conductors. What are electric insulators? Electric insulators are materials that do not allow current to flow through them. That means if they are there in the circuit, they will not allow the current to pass through. What do you think? What types of materials are good conductors? Aluminium, rubber, wood. Think. What do you think here? What type of materials are electrical insulators? That means they will not allow electricity to pass through. Glass, pencil lead. How would you know if they're electrical insulators or electrical conductors? We can come to know if they are electrical insulators or electrical conductors by testing materials. Because we being scientists, we need to test. So what do you need to test materials? What do you need for that? We need a bulb, you need a bulb holder, you need a battery or a cell, you need a battery holder, you need 3 wires, and you need crocodile clips. And you will connect them the same way that I have shown you here in the diagram. And you will see that when you connect them, the bulb lights up. If the bulb is not lighting up properly, that means the battery needs to be changed. Or there is some mistake in the connection. So you have to connect it properly, like the same way I have done. And this is called as a test circuit. Okay, that means you can test this. Test many things using this circuit. You can also add an additional wire. When you will add an additional wire, you can put materials inside. Can you see how your circuit is going to look when you're going to put an additional wire into your circuit? One from the bulb and one wire from the other end of the battery. Now supposingly if I put a coin in my circuit, what do you think? The bulb will light up? If it lights up, the coin is an electrical conductor because current from the battery is going into the bulb, from the bulb it is going into the coin, from the coin again it is going back to the battery. So it's like a complete circle here. So it's an electrical conductor. But if the coin, when you put it inside and the bulb does not light up, it's unlit, that means that coin is an electrical insulator, or that material is an electrical insulator. It is not allowing the electricity to pass from the bulb into the battery. So it's incomplete circuit that time. And also keep in mind that you should always check all the parts of the circuits are connected properly.
Hi, I'm Jared and welcome to Fun Science Demonstrations for Young Learners. Little message, Morse code, are you getting it? Our big idea today is that electricity needs a path to follow. And sometimes that path is easy to follow, woo, and sometimes it's not so easy. Some things conduct electricity and some things don't conduct electricity. And what's neat today is we get to experiment and find out what things are good conductors and what things aren't such good conductors. How do I do that? How do I show you electricity? I could bite down on this and get shocked and the easiest way is a light bulb. Watch. Our pathway, we have electricity flowing through the pathway, lighting up the light bulb. Sometimes it's easy. Sometimes things really allow the electricity to flow through it. We call them conductors. Take a look at this wire. Have a little metal end and it's covered with plastic. If I connect metal to metal, whoa, the electricity flows. It must be a good conductor. Watch what happens when I touch the metal to the plastic. No light bulb. The electricity is not flowing through that plastic. It's an insulator. It doesn't really conduct it well. So I have all of these cool things here to really test and see. Do they conduct electricity or do they not? Let's start with my favorite, the hammer. We have the metal part. Let's try it. Let's create our pathway. Oh, look at that. It's flowing through our pathway. It conducts. What about the wooden part? Wood? Wood. Electricity's not flowing. That must be an insulator. Wood, it must be an insulator. The screwdriver, another tool of my liking. Wait, the metal on the hammer worked. I wonder if the metal on the screwdriver is going to work. So we touch and touch. Hey, it's flowing. Must be a conductor. What about the plastic? The wood didn't work. Let's try the plastic. Let's form our pathway. It's not flowing. We call it an insulator. Another tool, a C-clamp. Metal. It's working. Conductor. What about a wooden popsicle stick? It's not conducting. Insulator. A glass marble. All right. Touch. Woo, it's rolling. Touch. It's not working. Must be an insulator. A clothespin. We have wood, we have metal. I'm thinking the wood doesn't conduct. It's an insulator. What about the metal band? Touch, touch. We have light. Electricity. Science is so cool. Hey, if you want to learn more, check out the links right below our video.
So what have we learned today after looking at the video? The video was very descriptive. It showed you about electrical conductors and insulators. Electrical conductors, like how you saw in the video, are materials that allow electric through them. Conductors like copper, aluminium, they're mostly metals, and non-metals like graphite. You saw in the hammer, you saw in the metal of the wood peg, you saw in the metal of the screw driver, they were all conducting electricity. And what else did you learn? You learned about electrical insulators. Electrical insulators are materials that do not allow electric current to pass through them or flow through them. For example, plastic, wood, rubber, and glass. These don't allow your electric current to pass through. For example, if you remember in the video, the plastic end of the screwdriver, the wooden end of the hammer, the wooden part of the wood peg, they did not allow the current to pass through. The popsicle, they did not allow the electric current to pass through. So all those things are electrical insulators. So I hope you understood the topic of electrical conductors and electrical insulators. This is a small game, a link of it. You can go have a look at it. It's sciencekids.co.nz. Copy it down. Obviously you can stop the video and you can copy it down. And then you can go and click on it and play the game. The site is very good. It's very interesting. You can find many games there. And hope you have a great day. It would be very nice if any one of you or many of you could make a circuit and you can show the experiment yourself, how you're going to see if these are things that you find in your house are conductors or insulators, and then you can take a video of yourself and send it to me on WhatsApp or anybody else on the school group on WhatsApp. It would be very great, and we're going to be posting it on Facebook and other social media. But do describe your class and your topic, okay? So have a great day, stay indoors, stay safe, and have fun. Goodbye.